Imagine a structure so vast, so colossal, that it engulfs an entire star, capturing every bit of its energy, a structure that could power civilizations far beyond our wildest dreams. This is the fascinating concept of a Dyson sphere, but what exactly is a Dyson sphere? Is it really possible? And if so, what would we even do with such an immense source of power? Today, we're diving into the physics, the possibilities, and the profound implications of Dyson spheres. The idea of enveloping a star with an energy-harvesting shell has captured the imagination of many. The term Dyson sphere was popularized by physicist Freeman Dyson in 1960, but the concept itself can be traced back to a 1937 science fiction novel called Star Maker by Olaf Stapledon. Interestingly, Dyson himself suggested that a better name for it would be a Stapledon sphere. However, the name Dyson sphere has become so ingrained in popular culture that we'll stick with it for now. A Dyson sphere isn't just a single solid shell. In fact, a solid Dyson sphere, as often imagined, is mechanically impossible. The forces involved would cause it to collapse under its own weight. Instead, Dyson envisioned a swarm of objects orbiting a star, sometimes called a Dyson swarm, collectively capturing the star's energy. But what about the physics? What makes a solid Dyson sphere so challenging to build? The mechanical stress alone would be immense, requiring materials far beyond our current capabilities. Even the strongest known materials like graphene or diamond wouldn't be able to withstand the forces involved. Moreover, gravitational forces within the sphere are tricky. Due to Gauss's law, the star inside wouldn't exert any gravitational pull on the sphere, making the entire structure unstable and prone to drifting, which could lead to catastrophic collisions. So, if a solid Dyson sphere is so challenging, why not make it thinner or lighter? Some theorists propose using extremely lightweight materials that could be supported by radiation pressure from the star itself. These materials would have to be incredibly advanced, far beyond anything we can create today. There are also ideas like using giant rings or multiple nested rings, which could spin to reduce mechanical stress. These would be easier to build and maintain, and could serve different functions from energy harvesting to habitation. But what about the star itself? Wrapping a star in a Dyson sphere would affect it too. The star would receive additional energy from the sphere, causing it to heat up and expand, while also slowing down its nuclear fusion process. This could theoretically extend the star's life, but it would also change the nature of the light it emits. This shift towards a redder light spectrum is interesting, but it also means the energy available becomes less useful, at least in terms of what we can harness from it. Why would anyone build such a structure? The original idea was to capture as much energy as possible, perhaps to fuel the needs of an advanced civilization. But in a more futuristic sense, Dyson spheres could be used as supercomputers, potentially housing the consciousness of an entire civilization in a digital form. Imagine a post-biological civilization existing purely in a virtual world powered by the energy of their Dyson sphere. The computational power of such a system would be unimaginable, capable of simulating entire universes. Interestingly, the best candidates for Dyson spheres might not be stars like our Sun, but smaller, cooler stars like red dwarfs. These stars are more common, last far longer, and would require a much smaller structure to capture all of their energy. Perhaps in the distant future, when our universe has aged considerably, advanced civilizations will turn to these stars, constructing Dyson spheres to outlast the universe itself. The concept of Dyson spheres is one of those rare ideas that push the boundaries of our imagination. They may be theoretical, but they force us to think about the future of humanity and our place in the cosmos. So, while Dyson spheres may not be within our reach today, they remind us of the incredible possibilities that lie ahead. Thanks for joining us on this journey through the physics and possibilities of Dyson spheres. If you enjoyed this video, make sure to like, subscribe, and stay tuned for more cosmic explorations. Until next time, stay curious.